good?
Yeah.
Okay, cool. Last couple of lectures we talked about, really what defines data science. We got a little bit into just sort of a primer on Git, a primer on Python. This lecture I'm a lot more excited about because we're really going to take the principles, the stuff that we learned in the past couple of lectures, and put it into practice, put it into use through scraping and data mining. So we're going to be looking at a variety of sources on the web, namely Twitter, and maybe a few others like Reddit, and we're going to be basically mining and extracting information from those sources. Before we sort of get into that, I just sort of wanted to review a few things on Python. If you guys could all open the class repository on GitHub. I just posted an update just a few minutes before class, but you should see, I need to push. Push to our ridiculously large GitHub repository. We'll be going through just a quick primer of Python, just sort of a quick review, and we'll just so we can all be on the same page on this data mining stuff. Some of the code you'll see in some of the scripts we run today will be unfamiliar, and that's to an extent okay. You'll have a chance to review that material throughout the class. Some of the tools that we'll be using, do involve a little bit higher level Python stuff. And if it's unfamiliar, that's okay. Just keep in mind that we'll have a chance to review this throughout the class. So if you go to all the material for this class is as usual under the Lecture 3 repository or Lecture 3 folder under Lectures. So if you could all go through that and download the exercises, just go through and download this. Yes, thank you. The world's slowest slide projector. So just download these and just make sure you should be able to all run them. But the first one, the one titled 00_Python_review. This is just sort of recapping some of the stuff from last lecture. A couple things that I want to at least touch on before you guys dig into this is the notion of iteration in Python, looping. Last class we talked a little bit about lists and basic data structures and a little bit on control flow. If we have a list of items, like so, again, lists can hold items of multiple types. So it can hold strings and numbers and so on. We can iterate through items on a list using a for loop. So using this syntax, if you could all open your Python terminals, sort of type along with me. If I have a syntax there, let me know. For item in A, print. What do you think this will output? So assume I'm in my Python terminal, right? By the way, when you hit enter, when you put this colon in and you hit enter, Python is delimited by spaces. Because I think the first programming language that I know of one of the only programming languages to do this, controversial at the time, but certainly a good idea. Oftentimes in other programming languages like JavaScript, Java, you need to scope blocks of code, blocks of related code, and so you'll see brackets. But Python, when you see the two spaces, when there's two spaces or a tab, it basically means that whatever is indented is within basically some sort of parent block. So you'll hit enter here, and you'll probably get basically a prompt. Type in print item. What do I get? What's my output? I'll give you guys a couple minutes.
repeated each of the elements of the list on a separate line.
Yeah, basically. As you might expect, I get basically iterates through. Basically, what it's doing here is it's assigning. Item is basically a label, a placeholder, and so it's as if I wrote. It's the equivalent of. Let me write this in blue. It's the equivalent of print 1. Print 2, and print 3. It's as if I did this each in sequence. So this item variable here becomes a placeholder for each one of these items in my list. So what the Python compiler is doing is basically saying, okay, well, I see that this is a list, and I'm basically going to, for each item in that list, I'm just going to assign that item to, again, item. I can call item whatever I want as long as I'm consistent. So I could call it, say, if I wanted to erase it, for the sake of example, I could put element here if I wanted to. I could put element in list. Again, it's just, what we would call an identifier. It's just the name of the variable. So that's just one thing I sort of wanted to cover before you guys, go through this review. Again, if some of you, if some of this is all just boring to you, or if some of you are familiar with Python, then be creative and sort of play around with this Python review script. Otherwise, if you're having issues, if there's configuration issues or you're stuck, let me know as well. But we'll give this, say, 15 minutes, and I guess we'll sort of recap at 7. Any questions, I guess, but before we dig in? Everyone can access this file, right? You should be able to. I hope so. Okay, cool. So again, just sort of another point. You'll see that some of these are questions. So the questions and comments, just give a short, answer. So basically, the purpose of this exercise is not just to run it and get a result. It's basically to step through each line. You should cut and paste each line in here. So let's say I open my Python, type Python, gets into the Python interactive console. Yep, sorry. So I type Pythons, get into the interactive Python environment. Make this bigger as well. And you can just go through and cut and paste each line of code. And then just answer these as in your own words. Cool. So yeah, we'll recap at 7 o'clock. Oh, you need to type Python. So right now you're just typing through the So see how, so right now there's something Launch, and there was just basically Launch platform, puts you in Python. Well, I didn't now, so now you're in Python. So notice how the clock changes.
Maybe I just always put it in PH. Right, yeah, but just
Run that Python file.
If you want to run it in my Python notebook, that's fine. If you want to run it in Python, that's fine too. Yeah, so that's why it's like a cool line out. If you run it in that Python notebook, it does actually doesn't show much at all. So it's meant to be run. Yeah, so I would go, so we can sort of break it down the slice. This is my list.
So I
And say, well, you should Python knows just like a different form.
And then, sorry, I have like, I'm having a sorry, finding
Okay, so it's like the repository, so, yeah, so type in ls, go to lectures,
go to lectures.
and then functions.
So it is data minus. Okay, so, okay, next.
Make sure you're up to date as well.
And now I can just do open, like,
Once again.
oh, yeah. And I'll see false.
So in other words, that's what you have to
And now I can just copy and paste.
Well, I think that's, good letter stuff, because that's part 3 of the lecture. Part 0, 0 is.
Okay,
You actually have, I think you're a bit behind, because I updated this at the, just at the beginning of class.
I just didn't get both, like 3 seconds ago.
Dedicated to others.
Yeah, it is.
So, maybe, fit class, actually, go CD into, lectures, and CD into lectures are 3. It's LEC.
Well, yes.
And then CD's exercises.
Yes.
So,
Yes.
Yeah, just that.
Okay, so,
So I don't know, for some reason, I think this might be out of date. Or it might be like referencing a little files, like maybe if you refresh that.
Exercises, yeah, it's.
I think, yeah, sorry. I have it under. I have these different records.
I mean, if everyone.
I'm not sure if maybe this is.
No, that's the one that I gave.
Users. So this is under your. Oh, this is a different folder. This is under this.
No,
This one. And this one. Yeah, so it's actually not two different folders. So one of your folders is out.
Got it. So, and this one, let's see what this is.
So I got it.
Basically,
When
we're going
I went to
override
like,
Okay, so it's not, this is not
I didn't save it.
Okay, so actually,
Something's going on.
You don't have to. I mean, you can access that. I mean, just like, you know, just do that.
but I
I
have
was
it.
thinking it's full,
I mean, it's
and
fine.
I closed it, so I can't see it. So I have to try again, and a lot of things randomly.
So yeah, this is it's really very awesome. So you know where that is?
Yeah.
Yeah, that's right. I mean, have you created my anything? And you're actually saying, oh yeah,
No, I wish life was like that.
this is optional. I don't think anyone
It's like those, statistical year, we're going to
yeah,
Nice to do that. That's sick. A lot of people did that.
Yeah, that's what they say on Pablo.
Everyone's like a human.
I know what about that.
So yeah, this is the note.
Yeah, but it's yes.
Any guesses as to why the more math module might not be working? So that works. But I think you need math module.
You guys are sort of blind too.
I tried that you did that. So math dot, so you more math and math dot. And that dot. Okay. It's new to me. So you put that in math.
Okay, what's that?
So you have to
Okay, cool.
read that.
Yes, this.
And then
Perfect, alright.
make math. Is that the case for virtually anything you import like that?
Yes.
No, not always. Most of the time, yes, but not always. So basically, Python is a module within. So in other words, it's basically a package, and the convention is in Python that when you import a module, its module name. The module name acts as what's called a namespace. So in the case of the math, it would be math.square root, or math.sine, or math.tangent, or whatever. But it's not 100% always the case. You'll see some exceptions.
Yeah, it is.
So, no. Yeah, so
There's not even absolute in I can specify a fixed specific on the side. There. Okay.
Oh, yeah, I can sign it.
Oh, yeah.
All right, how are we doing? We're almost there? We'll give it 5 more minutes. I realize that some of this stuff is sort of some new syntax and new concepts. So you know, if there are parts that aren't clear, feel free to skip that one problem and come back to it.
Using your Python?
To just like it's this one. I just like removed it. Yeah. I don't remember that it has to be some kind
You have to do it like you want.
right, exactly. The last one. And now you say like many years ago.
Python counts?
No,
Or-
we haven't part of this.
Oh, yeah, it's better.
Slash symbol. But you, it's kind of annoying. If you go all the way down, it'll figure it out.
This one?
Yeah. My friend actually did this right.
Did he?
Yeah. She did not do the. I asked her if she did that landing page, and she said, "No, of course not. It's terrible."
Yeah, the landing page is going to be terrible.
Yeah. So she wouldn't have any respect for herself. But she did do that.
How's it going? All right, let's go through it together. So the first few questions should be pretty straightforward. Does 5 equal 5.0? What do you guys think? True. just a caveat, this is not necessarily the true universally in all programming languages. It should be. Oh yeah, I'm sorry. Can everyone see this okay, by the way? Even those in the back? Good? Okay. So 5 equals 5.0 seems pretty cut and dry and true. In low-level programming languages, like C or Java, this isn't always necessarily the case. Python takes into account floating point error, but C and Java are less forgiving with floating point error. In other words, machines fundamentally have a difficult time understanding precise values. Because machines run on base 2, and the decimal system that we as humans use is base 10, there's always a bit of precision, there's a bit of loss of precision representing floating point numbers in any sort of computing system. And that's not something that's specific to Windows or Mac or Python or Java or C. It's just universally true. And again, Python is clever about this, but other programming languages are less forgiving with respect to floating point numbers. So for instance, sometimes you might see, and this is just sort of for your own information, sometimes you might see 4.999999999 whatever. You might see like for instance something like if you divided 5.0 by 1.0, it might give you something like this. But yes, short answer, this is true. What about this one? Is 5 greater than 3 or is 5 less than 3? Yeah, one of the conditions is true, so the entire evaluation is true. What if I did something like this? 3 is less than 5, or print actually, I'll make this as a string, right? So I'll pass this as Boolean result. What do you think Boolean result equals? Yeah, it equals a string true. And the reason is because it does a left to right evaluation. So it sees this as being false, and then it evaluates this code. So the OR, it's not actually passing, it's not actually returning true. No, it's not, I should, to prevent confusion, this is true. It will actually return this is true. If I set it to a value, excuse me. Yeah, I need to set this. Yeah. So in other words, if I reverse this, that's the key. This is false. So the first condition here is false, right? So it's like saying false. So it needs to, in order for a condition to be, if it's an OR condition, in order for an OR condition to be true, all of the operands need to be, basically one of the operands needs to be true, at least one. So if the first one is false, then it's going to check the next one. And then it's going to get here, and basically if I were to print Boolean result, if I were to print Boolean result, it will say this is true. Let's try it again with AND. So if I say AND Boolean result equals 5, do how I had originally, and make it the same as the previous one. What do you think? What do you think the AND Boolean result equals? What do you think this will print?
False.
It will print false. Why? Yeah. So does it ever reach this? In other words, if I put a print statement here, well, I guess it'll complain because but it'll actually never evaluate the second string here. Because this is false, it doesn't need to evaluate anything after it. If it's an AND, it just optimizes and says, if any of the operands of an AND operation are false, then the whole thing is false, because it's an AND. And so it doesn't actually, bother to print this, or actually even consider this line here. Okay. So this was sort of a new concept, ranges. What is numList? Well, numList is a range from, it's basically, this range function is sort of like a fancy way of declaring an array. So rather than, having to sit here and go 1, 1, 2, 3, 4, whatever, I can just basically call this range function. And now it's as if I had basically manually created that very, very large list, that very, very large array. How do I get the 50th value though? Yeah, so if I do numList, the first item, again, remember that arrays are 0 indexed in Python, and in most languages, arrays are 0 indexed. So the first element is actually element 0. So if I do element 0, I get 1. If I do element 1, I get 2. If I do element 2, I get 3. And so it's basically n minus 1, right? So it's basically if I did 49, then basically what I'm getting here is going to be whatever is in my brackets plus 1. And so basically access it by doing the 49th item. The point of this exercise really is to understand that the first item in your list, I guess I should say the 0th item in your list is the first item in your list. It's not 1. In R, those of you who've used R uses 1 index. MATLAB uses R index. Sorry, one-based indexing, but virtually every programming language has the same scheme where it's the first item is accessed by item 0. Length of numList. Again, this is pretty straightforward, but basically, what do I get here? I get 100, not 101. Well, I guess the point is here, really. If I say range, what I'm really, I guess, sort of, the reason why is this 100, not 101? If I do range 1 to 1, I get an empty list, right? So if I do range 1 to 2, it's not inclusive. So I should basically put a note. Ranges are not inclusive of the second operand. That's why the length is 100. And again, ranges build lists. They don't build, range is itself not an object. It's sort of like a helper function that basically just takes 2 arguments and gives you an array, or a list, I should say. We didn't really talk about slicing. So if you didn't quite get this, that's okay. But I just sort of want to show you, we can sort of be, Python gives us a variety of ways to output multiple values in a list. We can use basically an operator. We can basically access sections of lists at a time. So if I have new list, it goes to 6. I'll write it all up. In other words, each item in this list is actually exactly the same as it's indexed. I can basically I can use what's called range notation. This is called range notation. This is called range notation. The reason why this is, you'll start using this a lot. You'll realize how convenient it is to access sections of arrays like this. So if I do, again, I talk about things being not inclusive. So if I do new list 2 through 3, Again, this is, if I were to talk about the index, and we're going to talk about indexes a lot when we get to data frames. This is index 0, this is index 1, this is index 2, this is index 3, this is index 4, this is index 5, this is index 6. It's coincidental in this contrived example that the index is the same as the values. It's just to keep things consistent. But again, these values in this list can be anything. So when I talk about new list 2 through 3, what do you expect me to get? Well, I just gave you an example of 2 to 4. 2 to 4, again, I talk about these ranges being not inclusive. So 2 to 4 gives me a subsection of the list 2, 3, right? Not 2, 3, 4. So if I do new list, sort of extend that to range 2 to 3, what would I get as a result?
Just 2.
Yeah, I should just get 2. Just 2, or what is the type of the return value I'll get here? A list with 2 in it, yeah, exactly, which is different than just getting 2. Again, so if I do type, again, I have a list, I have an array, I have 2 wrapped in an array. So if I do type, and again, just to sort of reiterate the importance of always checking types, always know what type your functions return, always know what type your operations return. Type is very important. Type is very important because the operations that we're doing, certain operations, are specific to certain types. When we're talking about addition, when we're talking about, if I say num1 equals 5 and num2 equals 7, if I say num1 plus num2, again, I would get 12. If I were to say string1 equals ASDF, string2 equals FDSA, if I do string1 plus string2, what do I get? It's a concatenated result of the 2. The operation here is fundamentally different. And again, this is a very, very simple example, but common source of error, common source of bugs is getting a different type in a return value or interacting with a type that's different than you expect. If, again, we had this example in last lecture, but if I do string1 plus num1, what will I get? What will Python give me? What bonus question? What kind of error? It'll give me a type error. A type error means that I did an operation that didn't make sense given the operands of that operation. And again, you can argue that I could concatenate. I could plausibly concatenate a 5. I could convert the 5 to a string and I could add it to basically the string. Most languages, again, will let you do that. Python tends to be very formal and very, very strict when it comes to interacting with types.
Will Python ever converse, objects into other forms, or is it really?
Well, not typically. I mean, I can't say it doesn't ever do it, but.
That's because of the 5 equals 5
Yeah, it does it for Boolean types. Like for instance, an if statement. Like if I do if this is a string, it's sort of coercing this into a string, right? So in other words, this is evaluating to true. So Python will treat certain objects like other objects, and yeah, it does type coercion sometimes, but in general it doesn't. Did you want to elaborate on that, Josh?
Aside from the 5 equals 5.0.
Doesn't check the type of equals.
No, that's JavaScript.
Yeah. So the triple equals.
Because yeah, there's no sector.
Yeah, so the triple equals is Java specific, and it was considered a design flaw. In fact, you'll see the acronym. There's been a discussion on equality is always equality in every language. Like JavaScript is the one language where equality seems to have no meaning, and so oftentimes like some things, it's a discussion for another time. But in Python's much more regular and much more consistent with how it treats what's true and what's not true than JavaScript, which is sort of willy-nilly. So yeah, sort of going back on this, I can actually, this is sometimes called the sort of these nice syntax, these nice rules or ways of formatting things. This is sometimes called syntactic sugar. Basically, It's a nice, clean way of writing something that doesn't increase the expressiveness of the language, but makes things easier on the programmer. So this is basically, we'll call this syntactic sugar. You'll see this thrown around a lot. We can also sort of extend this concept of indexing and slicing arrays. I can say if I want to get from the third element to the end of the array, I can use this notation. In other words, there's no character here. It's not a space. It's just if I do new list 2 colon with nothing here, it'll give me to the end of the array. And vice versa for here. Interestingly, well, we know that 0 is the beginning of the array. Will -1 give me anything? Yeah, so -1, this is sort of clever, right? So -1 will actually wrap, Python will actually wrap, elements out of bounds, unless they're out of range. So basically if I say negative, I can do negative indexing, but I can't sort of extend, it won't wrap past 6. I can also basically, let's see if I remember the syntax correctly. You can also, this is sort of the answer to the question, but if I want to look at slicing a new list to return a certain section, I can also skip values. So I can say go from between the 0th element, 0, to 6, again not inclusive, skipping by 2. And so that will go, I can also say new list 2, was it 2062? And that will give me the array 0, 2, 4. Note that this is the start index. This is the ending index. And this is our interval. All right. Dictionaries. I mentioned in last class that dictionaries are very, very important. And we'll see sort of why this class. But really, there are various fundamental types that we deal with very often in programming. Chief among them are lists, dictionaries, and strings, and what we call the primitive types: numbers, floats, true values, characters, etc., etc. The reason why dictionaries are so important is because, in a sense, they can sort of represent almost any value. Almost anything can be represented through an association of objects. When we talk about getting information from an API, the information that we get is represented in a structured format where there's basically a label and a value, right? So those of you who've dealt with Excel, you have a spreadsheet. And at the column at the top of that spreadsheet, you have all of the attributes. So if we were to describe, say, a person, we could describe them by a list of attributes: their height, their name, their weight, their hair color. Whatever we wanted to do, we could basically describe almost anything as being an association of attributes. If we have many people, if we're looking at survey data, we really have a list of dictionaries in a way. We have a list of people, they all conform to certain attributes. So each person has a height, each person has a weight, each person has a hair color, each person has really a list of attributes that define that person. And so dictionaries become a very, very powerful way of expressing data, of expressing relationships, really attributes about an object. They describe really the characteristic of what makes up an object. And sort of ironically, dictionaries are also the fundamental data type for building programming languages. I mean, virtually everything internally with how Python works and how any programming language works is basically maps everything that we actually declare here, everything that we store internally at the operating system level, at a much lower level. It's basically mapping dictionaries, associations between objects, their entity and where they exist in memory. And so the hash is really sort of the king of the data structures, and it's something that we'll work with a lot. So I just sort of want to review this and have you guys be comfortable with it, and making sure that you guys can really understand what a hash is, what a list is, because we're going to sort of extend and build on these concepts throughout this class and later, throughout this particular lecture and throughout the class as well. So this is a simple dictionary, right? How do I, let's say, so I have a dictionary. I just declared a dictionary. How do I get 30 back? Well, let's say the first part of the question is how do I return 10? So I want to basically print, and I want this print to return to print 10.
So dictionaries with D,
Okay, D,
and then
bracket,
string C.
string C. What will C give me?
String A, sorry. Printing 10.
Printing 10. Yeah, I mean, if I wanted to print 30, obviously, print C. So I talked about last class, the concept of mutable objects. Not every object is mutable in Python. Strings are immutable. In other words, once I declare them, I can't actually change them. If I want to change them internally, what Python will do is will recreate the modified version of the object. Dictionaries, on the other hand, are mutable. If I wanted to say change, we just got back 30. How do I change D to, how do I change that value that I just retrieved to be a 40? Yeah, I can just basically reassign it, right? Oops, I want it to be 40. So print D, yeah, so now I get 40. So I can store anything here. Some key. So I can basically create a hash called person. And I can say person has a height of 170 centimeters, has a weight of 70 kilograms, has a hair color of, I'm going to say brown, has an age of 40. Oops. You have to put them in strings. So the keys are basically, they have to be an identifier. They basically have to be, something that would return. I could say, 9, but usually most of the keys within your dictionary will be strings. Oops. And so now that I have a person, I can basically, access certain values of a person. Person, their age, and so forth. Again, we talked quickly about looping. I'll go through this one really quickly. It's already 7:30.
Like syntax question?
Yeah.
Single or double quotation marks for strings or either exact?
Good question. The answer is it doesn't matter. So if I say, talk about equality in Python. So Python looks at strings basically whether they're single or double quoted the same way. This is a string, and if I say this is a string, it'll tell me they're true. The reason why it's good to have both is because sometimes when I'm within a string, I want to basically be able to put like an apostrophe, like Joe's Fish Tacos, right? If I could only do single strings, then I'd have a problem because now I'm basically outside my string. I can also escape. Like if I want to say Joe said, I can use a backslash to escape. So Joe said hello. This backslash escapes the quotation so that when I do the print here, or if I say evaluate it, then it'll treat that as a quotation character rather than being what's called a quotation literal. So it doesn't interpret it, it interprets it as though it's part of the string itself, rather than delimiting the string. All right, so I'll go through the rest of these pretty quickly. Again, this is just an extension of what I went through at the beginning of the class. This is iterating through each item in the list. Could I shorten this? How else could I write this, by the way? That's really the point of the question, but can I just use for fruit in fruits? And then can I just do print fruit dot upper? Upper, by the way, just basically converts that to an uppercase string. So if I say some string dot upper, you get the uppercase version. And again, I can call functions on literals. So we call this bare form a literal, a string literal. It's literally a string. If I call upper on that string, it acts the same thing as if I assigned it to a value. Some string a dot upper some string. Cool. I talked about hashes and sort of coming back to dictionaries. Dictionaries can be composed of dictionaries. They can be composed of strings. The keys themselves are identifiers. So when I talk about, if I talk about a dictionary like this, I have a dictionary, look at type locations. Again, it's just a dict object. If I do locations, Sinan gives me Baltimore. If I do locations of Brandon, it's Arlington, Virginia. What if I do locations of, or what if I do, this is sort of this dictionary has a nice, what you call a nice consistent schema, where it's person, location, but I could sort of, break that paradigm. What if I did location, person, call this person anonymous. Location.anonymous equals, remember I created person? So I create person. Created this just a bit ago. Now if I do locations anonymous equals person, what do you think my dictionary object looks like now? Yeah, so now basically I just sort of injected the values. I just basically nested that dictionary within the dictionary. So I just have a dictionary object. My original dictionary object of person is now mapped to, or I should say the anonymous key, the anonymous string, maps to that person. This example, the nums example, is sort of interesting because this is what we call a list comprehension in Python. And I'm not going to quite have time to go through it in detail, but just as I can sort of, use this syntax to quickly query lists, I can use list comprehensions as sort of a short form way of building a list. So it's basically I'm constructing a list through a loop. The previous example, the previous example, I should say, we looped through a series of items and we uppercase them. Here we declare a list, and we basically loop through each item. Again, this is the exact same syntax we covered in the beginning of class. If we just look at what I'm selecting here, it's the exact same syntax we had in the beginning of class. I'm just taking, for each num in nums, I'm just taking that number and I'm rebuilding a new array by multiplying each of those numbers by 2. This is called a list comprehension. So if I look at really what the result was, I have 2, 4, 6. The equivalent syntax, if I did sort of, this is again what we call syntactic sugar. Sort of the longer version, the non-syntactic sugar version. If I did for num in nums, and I pre-declared an array, so I'll say this, I'll call this new list. And I'll create it to be an empty array. For num in nums, I would have to do nums.append num times 2. And if I'm correct, So go print out the new list. Oh, sorry, new list.append. What's wrong with new list? I don't know, something wrong with my, it's not printing. But anyhow, really what we're doing, these list comprehensions are a very, very powerful way, very, very expressive way of building arrays from existing collections. And again, this last example, we'll leave this as homework, because those of you who haven't, we'll review on your own. The question is, though, how would we sort of do that in reverse? How would we turn this fruits into a list comprehension? In the interest of time, we won't do that in class. All right, questions, thoughts, issues? Did anyone have encounter any unexpected issues? Or is this stuff all pretty straightforward?
Maybe a really basic question, but so for that array just above, we call 1, 2, 3 nums, and then we set num times 2 for num and nums. How does it know that 1, 2, and 3 are referred as a num? So we didn't actually declare that.
Well, remember this example here? It's basically doing the exact same thing. Remember this num, we called it element in the first example, right? So first we declared an array. We declared an array, and we iterated through each item in that array, and we basically declared an identifier, which is sort of basically temporarily assumes the value of each item in the list. I'll call it references. It temporarily references each item in our list. In this example, we called it element. In this example, we're just calling it num.
Right.
So it's basically for each item in the list, it's saying num is 1, then num is 2, then num is 3.
So any identifier we put after the 4 assumes each value in the list?
For list comprehensions, yes.
Okay.
Note that this is sort of an exception because the num, this variable, the scope of this variable in list comprehensions exists within the array. Typically, though, if I do a for loop, loop item in nums, I believe that loop item will not be declared, will not exist outside this scope. So let's say we print loop item. Loop item typically does not exist without the body of the for loop, except in list comprehensions. So in other words, loop is then undefined here. So that's just a caveat to keep in mind.
Got it.
All right. Any other questions, issues, thoughts? Actually, I may be mistaken. Josh, do you know, is loop item defined? Is the script retained? Huh?
It's a language about how space and Python. It should be undefined.
Yeah, in Python, so that's another sort of difference between Python 2 and Python 3. In Python 3, this would be undefined. In Python 2, it's still defined.
It should be undefined. You should pretend it's undefined.
Yeah, you should not use it outside of the for loop. I mean, that's sort of, yeah. There's no reason to. You shouldn't retain the value. The language should not retain the value after the for loop. Okay, other questions? All right, so this is really the last time we're going to take in class, like really reviewing and talking about the core nuts and bolts of Python. Next week we'll talk a little bit about pandas and NumPy, some of the tools we're using within Python. But this is the last time we'll be talking anything or really like going through examples specific to the language itself. As was mentioned in your course intro packet, and as is sort of mentioned also in the course README, there are a bunch of great resources to learn Python, and so I would strongly recommend that those of you particularly new to the subject would review each of these materials and, if possible, complete them. The one that's most popular is this first one, Learn Python the Hard Way. I'll send these out on Slack right now, but this is just sort of for your own benefit, for your own help. Because yeah, this stuff does take time to learn, and it's not stuff that we can commit a lot of time in class to learning. Because there's so much in this class that we have. There's so much wood to chop in terms of stuff that we'll be learning that's particular to data science, to machine learning, and so forth. So we want to sort of get this Python stuff out of the way so we can move to the more interesting concepts. All right, moving along. Today we're going to have a lot more fun, I think, than this Python stuff. Sort of putting this stuff into practice, talking about really how we mine, how we extract, how we get, parse, analyze data from the internet, from large sources. It doesn't have to be the internet. It can be from all sorts of sources, but most commonly, the internet's a pretty large source of information. Oftentimes, it's difficult to, the most difficult thing about analyzing really any data set is dealing with inconsistencies in the data that you receive. What I mean by that is typically when we're looking at a website, when we're looking at, so say we want to, I'll give an example here, which I'll come back to later. Something that you guys should all be familiar with is reddit.com/r/data is beautiful. There's some amazing graphs, some really cool stuff in here. But as an example, let's say we want to build a crawler. What if we wanted to build and extract meaningful information from a site like reddit.com/r/data is beautiful? How would we go about doing that? So, this is going to seem kind of obvious, but the first thing we really need to do, if we want to basically scrape a page, or if we want to extract information, if we want to mine, we really have to be specific on what we want. The internet is huge, it's massive. So let's say I want to look at, the first thing you really do is define really a question to the answer. What is our objective? More specifically, what question are we trying to answer? So hopefully we have some objective, some question, some purpose. Otherwise, I don't know what the point is to begin with. But really, from there, we'll ask what data do we need to answer this question? Sort of I'll put this as basically part A, and part B, where do we get it? Again, this stuff seems pretty straightforward, pretty obvious, but you'd be amazed at how much time. The reason why I spend 10 minutes in class to cover this stuff is because people sort of jump in head first and they sort of start scraping, they gather all this data, and they don't know what to do with it, or they really sort of focus their resources and waste a lot of time, or vice versa. They sort of ask the wrong questions and get the wrong data. Data exploration, machine learning, data analysis is all really fundamentally about answering questions, and from those questions, formulating hypotheses, and from those hypotheses, validating some sort of model, or formulating some sort of model that can effectively predict and hopefully generalize to data that we have not yet seen. And this is something we'll be covering for the next few lectures. But really the fundamentals come on how you get your data, where you get your data from. So sort of put an addendum, sort of amend this comment, say there's really two sources, two types of data. We have unstructured data, and we have structured data. Unstructured data is data that's, in a sense, easy for people, for us humans to understand and interpret, but difficult for machines to do. Structured data is pretty much the opposite. When we're looking at stuff like an encyclopedia, we're looking at something like an audio file, a movie. Most of the stuff that, the irony is that, we as human beings are very good at understanding and analyzing data. We're very good at finding patterns. We're very good at parsing data that machines have a very difficult time parsing. And so in order to get data from a raw format into what we'll call unstructured format into a structured format, we need to basically be able to parse and be able to have algorithms that can extract information, unstructured information, and turn it into structured information. So we'll put, I guess, up here, put unstructured data. And here we'll put structured data. Sometimes, by the way, the difference between the two is not all that significant, and you can have sort of like a hybrid semi-structured or semi-unstructured. We'll talk about that as well in a bit. We'll put some examples up here. An encyclopedia would be an example of, well, I'll sort of, I don't know, generalize a bit more. We'll talk about an audio file, a picture, an essay. What about a tweet? Would a tweet be structured or unstructured?
It's a string, but it's got associated metadata which can be structured.
Right. So sometimes you have data that's sort of in between, right? We have metadata, we have tag data. A tweet itself, the raw text of a tweet is unstructured. But a tweet comes with things like metadata and relevant info about that tweet. Same thing about audio files, right? Like MP3 files, like they have all this metadata tagged, how long it is, what's the encoding. So, you know, sometimes most data formats have a form of both. So I guess we sort of have a category here called semi-structured. But again, I don't want to, I guess, sort of, it can sort of be, I guess, what we call semi-structured information, sometimes both. What about, I don't know, what about a web page? What about this? What about, is this page on Reddit? Yeah, I'd say it is semi-structured. But if you had to pick one.
I would call it structured, I guess. It's got, tagged stuff.
I would call it unstructured. And I guess, you know, it's sort of like you say tomato, I say tomato, but it's unstructured because it doesn't adhere to sort of a central, what we call a schema. So some examples of structured, well, I guess I'll sort of give some examples of structured data. A database table. Database table in SQL is by definition structured. We'll call these like sort of like a spreadsheet, similar format. Spreadsheet of survey data. And again, assuming it's consistent for it to be structured, as long as it has a consistent schema. What are some other examples?
CSV file.
CSV file doesn't necessarily, most of the time, yes. A CSV file is sort of like an implementation of a spreadsheet in a way, right? CSV files are usually structured. I'll put this sort of survey data / CSV. I'm going to throw a word in here called the data frame, which is basically the same data structure as a spreadsheet. In other words, we're dealing with a series of columns. The columns are a series of attributes, and the rows are a series of observations on those attributes. You can call this any sort of coordinate system. You know, Cartesian coordinate system is an example of structured data. In other words, like a list of XY coordinates. Battleship is structured information. The coordinate systems in chess are structured information. So I guess really what defines structured data is a consistent, what we call a schema. In part one, let's say we want to scrape this page. Let's say we want to scrape Twitter. And we want to see which words are most popular, which words are the most popular pages on Twitter, right? So there's some words that maybe have a high correlation with popular posts. So we basically need, there's a variety of data points that we might need to do this. So coming back to sort of our objective, define a problem / question. And that'll be, we'll say, what are the most popular buzzwords? What are the best buzzwords for me to put in my title? This is our objective. 2, I'll ask you guys, what data do we need to answer this question? So what data do we need to answer this question?
The title, the ranking that you have, and some other meta, like popularity, number of comments made.
Yeah.
Upvotes and downvotes, differential.
Okay.
Probably want like a time frame, so you know how much time has elapsed.
So I want to, in other words, if a post is new, it might not be as interesting. So let's say, an average post has a lifetime of, I don't know, a week. And so if it's younger than a week, then you're still getting some data. Someone said, basically, the words in the post. Someone else said, number of comments. Someone said upvotes and downvotes, and I guess the net difference between the two. I'm just going to call this upvote score. In other words, we're just going to care about the difference. Actually, no, I think that's a good question. If we want to look at number of upvotes and number of downvotes. What else? I think you said time or the age of the post. What else? I think this is good enough to start with. By the way, what data type is this? What's my data type here?
Integer?
No.
It's a list of
It's a list.
of words. Yeah.
What's this one? Standard in. There's obviously also an in. There's also an in. Not this one.
Some kind of timestamp?
Would a timestamp be good enough though?
Minutes from a certain date.
I would say that's actually interesting because you could use a timestamp. If I know the date today and I know when it was created, then just the difference between the two. So I could use a timestamp. I could also use a duration object. In other words, I could look at, I could turn a timestamp into duration, but I would argue that a timestamp is actually better because a timestamp is static. In other words, a timestamp doesn't need to be updated because it was only created once. And I would basically say that I think you raised a good point that really the timestamp of creation is more valuable. And this has a specific data type that's usually called the date time object. By the way, there's basically, when you're dealing with dates and strings, there's a date time object. And there's also, usually there's a date object, which is responsible for tracking dates. And then there's a time object, which is a data structure that's just intended for tracking times of day. And the union data type between the two is called a datetime object. In other words, it has features of both. But most language, most paradigms have a distinction between date and time. Sometimes you care about time, sometimes you care about date, sometimes you care about both. We'll say that this is a datetime object. Okay, great. So now what? Well, this stuff, all this like fancy page, is really just, mostly just clean CSS, just images, a lot of stuff that's not relevant. 99.9% of the stuff that's on this page is not relevant to me. So I'm not actually going to be processing this part of the page. I'm probably going to be looking at, really the raw HTML. This is what we call the DOM, by the way, the Document Object Model. So just sort of put this up here, because it's common terminology. The structure of a web page is called the DOM. Which is the document object model. It's all the stuff that comes together to make a page. And the reason why it's called a model is because you can think of it as being basically sort of like a tree, or sort of like its own sort of dictionary in a way. You have really the HTML. Hide this for a second. If we were to sort of look at part 2, the answer is really looking at the DOM. So if we look at the HTML page, we have a series of tags, right? We have an HTML tag. We have a head tag, which has all the sort of embed information, stuff that's not explicitly rendered on the page, but defines all the dependencies in the page. Those are usually closing tags. And then we have, say, a body. And then within that body we have, I guess within the head we have, say, like a title, for instance, which may or may not be relevant. Within the body, we have usually a variety of sections, and this differs per page. So the sections, and then we have paragraphs, we have headers, etc. You don't need to know HTML for this stuff. Just sort of showing, giving the premise of why we're doing what we're doing. By the way, isn't this really, again, just a dictionary? Couldn't we represent a web page through a dictionary? If I gave you a dictionary and I said, this is the HTML, right? It's a nested dictionary, HTML. I can say head. I can say title. And title would be a string. In other words, that's what's actually displayed in the tab. I can say body. And again, this is why I say dictionaries are very powerful, because the expressiveness of HTML, what we can do with HTML, we can also do through a dictionary. And I think this is also why you said HTML is sort of structured in a way, because the HTML document itself does have structure. There is, for every web page you see, it will have an HTML tag, it will have a head tag, it will have a body tag. But the issue is that we need to get this, all this stuff that isn't, the stuff that's general, that's not specific to the problem we're trying to solve. We need to extract these attributes. In order to solve the problem we're trying to solve, we need to extract these attributes from the DOM. And we do this basically through pattern recognition. We do this through basically looking for where certain tags are. So, turn this back on. I don't know why there's two remotes. You can actually, in your browser, sort of interactively play with a page. For those of you who have taken web development, or those of you who are familiar with web development, are very familiar with having to query different elements in a page. But it turns out that the information that we want to find is usually very cleanly nested within some sort of tag. I'll blow this up a lot. So one of the attributes we care about is this upvote number, right? So if we were to right-click, you can right-click anywhere on a page, and you can see, really what we're. You can actually see the actual elements of the page that wrap and that make up that element, that text that we're looking for. So interestingly enough, we see score dislikes 2941, score downvoted, score likes. So basically, I think what we're really looking for is this one. I think that these look suspicious. So in other words, I guess when you like it, it'll go up to 2943, and when you dislike it, it'll go to 2941. So the unvoted ones are 2942. And I don't know, I didn't design the page, but if we can find this pattern, if we can basically crawl within the page and find this specific pattern, then we can basically target and extract this information. And because we have to do this extra step, because we have to crawl through and sort of extract information from this page, this is why we call it unstructured, because we sort of have to be clever and we have to come up with our own ways of scraping and mining this page. Sort of show you another example, just so you guys are at least somewhat familiar with this. If I go to yahoo.com/finance, let's look at the Apple stock. Again, let's say I wanted to call through all of the, there's a bunch of interesting information here. There's a lot of information on this page that's very relevant. And so I could basically look, right-click, inspect element, and pull this up again. Again, I get an idea, I get a specific number here. I see a certain pattern that pertains to this number that I'm trying to find. And so if I can really find a way of identifying this number with this string within the page, I can from there basically extract this nugget, this piece of information that I'm trying to mine. And there's a very important tool that we use for doing this, for recognizing and matching strings within strings, or substrings, particular patterns within a large string. And we call those regular expressions. So basically, we extract patterns in text through regular expressions. Regular expressions are a standard. They're not specific to Python. They're not specific to crawling the web. It was actually invented at Bell Labs during the Unix days. Back when programming languages were first being built, these things like identifiers and being able to find text and being able to do what's called tokenization. It's very important that you have sort of a simple language for expressing how to find and how to identify items and keywords in text. And so this was actually developed with the purpose of building programming languages and sort of standardizing a way of building programming languages. It was developed by a guy named Brian Kernighan. At Bell Labs. And along with Dennis Ritchie, who was the author of the C language. And it was first implemented, I think, in a language called B, which was the precursor to C. And this is sort of a tangential history lesson. But the point is that they established these standards, these regular expressions, that are still, to a large degree, standard today. They've changed a bit throughout the years, but the principles and the underlying foundations are more or less the same. So we'll work through an example of how to really apply Python and how regular expressions work. They're actually rather simple, but like anything else, it requires practice. But again, these regular expressions are extremely, extremely powerful, and they're tools that we'll use all the time. I'm going to paste a link onto Slack that you guys should follow. So pull up this page. This is basically sort of a test, I guess sort of like a test tool for analyzing and evaluating basic regular expressions. So typically we have a body of text. So we have something called a text body that is a large string of characters. And let's say if we want to find a particular pattern within a string, we define a pattern to be matched within the string. This is what we call a regular expression. And basically, the process of, if we have, say, text body, we can sort of take a function, basically call this match. If we have a large body of text and we have a regular expression, we can match them and basically get a filtered result. In other words, a substring of text body that matches that pattern. I'll give an example. So, for instance, here we have a test string. I can type anything here. This is just free-form text containing one or many words. Let's say that I want to find all digits. So I want to basically find a way of matching within this string. I want to be able to match digits. Oh yeah, sorry. Thanks for always reminding me of that. If I want to match digits, in other words, I don't care about anything else. I just want to see what's numbers in this. There's a certain operator that matches digits. And what's cool about this Python tool, this regex tool, is that it sort of gives you an explanation. This \d is called a meta character. In other words, it's not interpreting the literal \d. It's treating it as though any digit. There's also a few modifiers I can use. So I can tell it to globally match all digits within the document. If I take this out, it'll match the first one. Typically by default, when you do a match operation, it'll match the first digit, the first token. Typically, usually a fancy programming word for talking about words within a string. These are called tokens. It'll match the first token with that matches the regular expression. If I do -d+, I'm telling it to match as much as it can, one or more tokens. And this is called a greedy match, because it'll actually try to 2 matches one or more digits, 20 matches one or more digits, but it'll try to match the largest substring that it can that qualifies, that matches that pattern. If I did \d/\d, it would match, again, this 20 and this 15 separately. If I were to do this again multiple times, it would match the 2015.
So when you did 2, just cut it into 2 different, just cut it in half, basically?
Yeah.
So depending on the number of Ds, you would just separate them by half.
Yeah, and I think it would actually find 3 here. It would find 20, 0, 1, and 1, 5. I'm not sure if they're mutually exclusive. It depends. Some of this behavior depends on implementation. So, sometimes it would find 20 and 15. Others might find 20, 0, 1, and 1, 5. But this looks like it's doing it, not overlapping. So in other words, yeah, digits were those groups of 2.
What's the G doing in that?
G is global. In other words, if I take out the G, it'll find the first one. G means global. So if I go back to digit here, then it would find each one as it exists throughout the document.
Is there documentation on all the things that you could do?
Yes. In fact, it's all here. It's all within this. So there's tons of, yeah.
It could be a long class.
Exactly. There's tons of this is something that once you understand how it works and you have the documentation, that's most of what you need to put this stuff into practice. Again, it does differ sometimes by languages, but all of the documentation on this stuff is here under this quick reference. And it's just something like once you start practicing this stuff and you put it into use, you'll get more and more familiar with it. But it'll come pretty quickly. Let's say an example would be if I wanted to match a phone number, a specific format of a phone number. So this is my phone number. Again, if I just type plain text here, it'll match that plain text. So if I have, if I match the string or, it'll match both the OR and by the way, I'll have to have the global flag set. It would match the OR in the free form, the OR here, and the OR in Word. What regular expression could I use to match a phone number?
You put 7 \Ds. I won't quite look for that, but
Well, if I did 7 \Ds,
You do 3 Ds
dash.
dash.
Yeah. Yeah, so I do 3 Ds, and that's going to match both the 805 and the 403, followed by the dash. Now what? Okay, if I do 4 Ds, that's good, it matches that part. Yeah, I need to have the error code, right? So now it finds, it matches this, it has one match, which matches that number.
What do you do if there's inconsistent data? I mean, people, let's say you're finding phone numbers, and everybody enters in with your dash or no dash.
Then you have to get, that's when things get messy. So let's say we had something, let's say I had a list of numbers. So someone entered it with, you know, without this error code. Someone entered it with, you know, like this. Then it would become a very complex regular expression. And you know, maybe we could cover that, you know, for homework or something, or for later. But yeah, it gets messy very quickly. And there are times where you can't quite fully match whatever you want to match with a regular expression, or you have to use some like conditional logic, or you have to sort of be clever. But you know, if someone say entered it like this, there are ways of handling this. Like I could say, if I put a question mark after a identifier, it'll say basically, it'll match this now because it'll say if there is a dash included in the regular expression. So now it says whether there's a dash or not. That question mark allows me to say, well, if it's present, include it. If not, then you know, omit it. I could also do that. I could sort of group these together and say if there's an area code, include it. If not, don't include it. So now you can see I have a pretty comprehensive match. I'm matching all of them. I'm not quite matching this one. So I could sort of, again, create another group. The parentheses, you know, create these groups. And I won't go into this stuff too deep. I don't know where it went. Did I just lose it? No, I think I just lost it. Where's another tab? Oh, here it is. Wait, no, it's not there either. Okay, but you know, I can basically compose. I can compose and sort of create regular expressions from regular expressions.
So including a string, you can use different wildcards to say, including a tweet, you got the status, and you got a number, and then you have...
Right, exactly. So, you know, going back to this example, you know, I could basically, I'll copy this. So I have this, you know, long string, which is basically just a section of the Yahoo. This is part of the section of the DOM for the Yahoo page on finding that stock price on Apple. And looking at that, so I just cut and pasted basically this section of DOM that I was interested in into this regular expression, just as an example. And we have this interesting thing, this interesting class called timeRTQTicker. So in other words, if I can find timeRTQTicker, I can probably also, you know, within that find where that particular ticker is. So how might I do that? In other words, I want to be as specific as possible, but I don't want to be so specific that I exclude what I'm looking for. What might a regular expression for that look like? Again, I want to find this. I could just type the raw data. In fact, I think in this case, we can see that raw RTQ ticker does match. But I also might want to sort of, be more specific and match this string. The problem is that, within a class, I might also have some other class here. I don't necessarily, I don't want to assume too much about the data that I'm getting, because it might make things fragile. And, in HTML, we can have one or more classes per element. So if I want to say find time RTQ ticker that is within a class, I could say class equals, and obviously that won't match. And I'll have to escape I can find a quote, and I have to escape it because, just like I showed you earlier, you have to escape the quotes, I think in regular expressions. But the problem is I basically want to skip anything that's not relevant. So I'm going to put this dot star here. Now, what the dot star does is it says any number of anything. So find a class object, and then find whatever, I don't care what is between where this quote is and where time RTQ ticker is. Just be greedy and find as much as possible. And again, if I did another dot star here, you can probably imagine what would happen. I would basically include the rest of the page. But I want to close that basically where I have this closing quote. So time RTQ ticker, it's a little bit too broad, isn't it? Because I'm finding basically anything I'm finding basically non-words as well. Remember we had the \d for digit? I'm going to put the \d for word. In other words, I want to find \w for word. In other words, I only want to find characters that are similar to words. But I also need to include spaces. So I can include spaces or words. And now that I think of it, I'm not 100% convinced that this is possible with entirely regular expressions, but I've gotten pretty close. So I've matched class. So I've basically it starts from left to right, right? So you can imagine basically I'm scanning left to right. And I'm saying find class, it finds class, find equal, finds equals, and then again I have to escape the quote, it finds the quote. And what I'm doing here is this within the bracket is like an or. \s means any space character, \w means any word character. So, by the way, these are both lowercase. Lowercase s and lowercase w will match uppercase s will match anything that's not a space, so it negates that. And uppercase w matches anything that's not a word-like or word-like character. So I'm saying if it's a space or it's a word, for any number of those, match that. So it's basically automatically expanding my selection. And then it's saying, okay, well now I'm a little more specific, so I'm going to match this time RTQ ticker. So it matches this. Note that there's other class, if I took out this time RTQ ticker, it could match any class string within the DOM. So it tries to be as specific as possible, that's still with finding a pattern that still matches this regular expression. So it finds a time RTQ ticker, and then it finds this something other, etc. Now I can expand that further, and this sort of stretches the limits of what we can do with regular expressions. But I can also put a span here. And it would basically match as much as I could within the span. So basically, it gets a little bit confusing, a little bit hard to read, but basically I'm including everything that I included previously, but I'm globbing as much as I can within the rest of the document. So okay, we'll quickly go through a Python example of this. You have in the same exercises folder a 01_RE_example. if you run that script, it'll basically show you how that works in Python. So Python has a module called RE, which is just this regular expression module. It's just basically a module within Python that is responsible for finding and matching patterns. There's a variety of examples here. But I want you guys, sort of in a similar fashion to what you did in the beginning of class, go through each one of these. We only have time to do it for about 10 minutes or so. But sort of explore each of these. Try changing things within the string and seeing what you can break and what you can allow to work.
Try changing it where?
So you should see basically this file, the 01. So I'll run through it, I guess, quickly in the interest of time. But if you run it line by line, you basically, first we import the regular expression. This is sort of similar to what we did from the first homework. Import regular expression module. This is just a function I defined that helps sort of print. It's a sort of a subroutine that helps me print each particular item. But let's say I have a string like this. Remember, this is just a raw text. It's nothing. There's nothing fancy about it. It's just a string. If I say re.compile, I'm basically building. That's a syntax within the regular expression class for building a pattern. So I'm basically building a pattern. I'll sort of cut and paste this into here as I go along. I'll take off the quotes. If I do \d, you can see it matches the 2. If I do G for global, it matches the 2015. And I'm using this re.findAll, which is sort of the equivalent of doing the match with the global modifier. But if I run this section of the code, the findAll pattern will find each one independently. It'll find the 2, the 0, the 1, and the 5. If, however, I use the D+, it'll find. Well, I guess I'll ask you guys. It'll do a similar pattern match, but what do you think it'll print?
2015.
Yeah, so it'll print it all at once. So it'll basically group it all together. So it's greedy. It's matching. It's saying find 1 or more digits. So it's going to say, okay, well I have 4 digits here, so I'm going to greedily match the largest string I can that matches that pattern. We talked about OR. Basically, in other words, the bracket matches one of the items, one of the particular pattern, the tokens within that bracket. So it'll find a C or an F or a G. It won't find the literal text CFG. So, given basically just the first seven letters of the alphabet, what do you think this find will return? So alphabet is just the first 7 letters of the alphabet. My pattern is just this CFG. What am I going to find? I'll just find CFG, right? Whoops.
Why wouldn't it be nothing? Because there's no consistent CFG.
Remember, it's OR. So it's finding one of the items present. So it's finding a C or an F or a G. So for instance, if I did, let's say I did cat, right? Then it would find, if my regular expression, if I did re.compile, if I did string if I did something like this, C, A, or T, this would match, right? In other words, it's saying if it's an A or an O, then match it. So it's going to find the C. It's going to say, okay, I've got a C. It's got an A. Is it A, an A, or an O? Yes, it's an A or an O. Is T a T? Yes, T is a T. So in other words, it would match if I did cat string, but if I did cot string, I did cot, it would also match cot. Make sense? So in other words, when I go here and I run this, it finds the C, the F, and the G. In other words, it's finding the C first, and then it's finding the F, and then it's finding the G. And it's greedy, so it's returning, well, I'm actually calling it find all. So it's finding all of them. If I did find, again, this is Python, sort of the Python convention for strings. If I did find, oops, I think it's find one. If I did search, if I did search, it'll basically, there's various ways of calling this stuff, but search basically finds each one in a group. Find all returns a list. I find all to be the most useful because it will basically greedily find as much of them and return them all.
So, like, will we ever be using any of like the find methods in, that come with Python, or will we just be using it already?
This does come with Python. This is the native way to do it in Python.
Okay, so what it means is like we have to import the.
Yes. So there's a bunch of modules in Python that are what are called part of the standard library. RE is an example of one of those that's of a module that's part of the standard library. In other words, when you load Python, it doesn't load it by default because you might not be using it. Python tries to load only what the bare bones stuff that you need. There's all sorts of stuff like processing dates, processing regular expressions that's within the standard library that you might not be using on a day-to-day basis, but it's there if you need it. And regular expression is one of those modules that it's there if you need it. And I didn't use pip install to install RE. It's part of the Python native standard library. Again, just sort of go over the cell phone example. This is the same thing that we went through in a few minutes ago. This is the regular expression to match a digit. So you can imagine, if you're wanting to find things like an email or whatever, there's going to be times when you want to find a certain pattern. Yeah. So for instance, this is an email pattern. If we have it will match. If we have an email, something that matches an email address. And again, this really depends on what your. There's a lot of like weird and wonky conventions for email addresses, but basically it's finding a word character or a period, any number of those followed by an et, followed by some number of characters.com. I mean, we might have .org here, right? Or we could have, so it's not necessarily going to match. There might be some false negatives, but yeah, regular expressions are very, very powerful, and they're used, really throughout all sorts of, web development, programming, data mining, data extraction, program language design. So, yeah, any other questions?
And so basically, once you define that, or especially when you define that into a specific library or class, or
What do you mean by?
once you found the register.
Yeah, exactly. You could write a method if you want to say reuse that, right? I could basically create, a function basically saying def is phone number. And let's say I passed a string into this, and I can just sort of go back here, and I can really create higher level functionality from this lower level behavior by saying, call this phone pattern, and I can basically just say re.search, if re.search, phone pattern, phone string, return true, else return false. This maybe isn't the cleanest, most concise way of doing it, but this would work, right? Because I'm basically searching, I'm using the search method to see what it returns. So phone pattern, if phone string matches phone pattern, then search will find a value, and it will return can even use find all here. It will return basically either an empty array, or it will return, a list of strings that match. And if it returns an empty string, then the if will evaluate to false. And so I could basically say his phone number, 805-436-404. If I did everything right, which I'm not 100% sure I did, but if I did everything right, then it should return true. If I do some gibberish value, then it will return false. So yeah, again, very, very powerful. We can define higher level behavior from lower level regular expressions. I could have, just do the same thing. I have def is email and do email string. And just doing sort of a similar paradigm. All right, let's take a 10-minute break, and we'll come back, and then we'll sort of close it off with API scraping. I'll see you guys at just after 8:50.
So if we wanted to scrape something, let's say a specific page,
We're going to talk about that right after the break.
We're gonna talk about something that's regex for web, right?
Yes. Beautiful soup.
Yeah. Sorry, my friend's husband wrote that.
Beautiful soup, really?
Yeah.
It's pretty popular. There's several of them. I forget the one. There's Rubular. So Rubular is sort of similar, but it has basically, a guide to all of the really all the rules of regular expressions, and also has sort of this interactive, console that you can test strings in. So this one is also very useful. I'll post that. Yep, we'll go through that. Yeah.
By doing it last week, so like how long it found the sweet stuff was in user API to pull back.
Yep. Well, there's an API, and we'll be going through the API. We're going through right now we've talked about the HTML, like sort of like how just look at the HTML, and the other way is looking at the API itself, which is a lot easier. Yeah. Well, you can just query the API and just say, I want to search these terms, or I want to, look at this specific data. So it's much easier than just like using a URL.
Yeah, exactly. Should implement the data science skills.
I think it's really good. But the chances, I don't think he did it again this year, and he proved it last year. It's a one in every year. No, it's a one in 7.
I mean, it's not as much like the numbers. Yeah, that's right. Like, no one ever take like a 16-year-old on. Most people think we're sort of like permutation. Yeah, it's still like.
I mean, there were 2. Yeah.
Yeah. No,
Great. I didn't even also hear you.
Like last year, I was trying to like, yeah, I just found more.
We have one set in place in a pretty large
What's the vibe?
Oh yeah, I know that.
You love to shit on anything off the top. That's ridiculous.
For what? Dot is a wildcard that means anything. Space is \S. Hmm? Yeah, I just posted on
Oh, this one? I can make it a lot. Take my evidence. Still stuff.
So I like studied that a lot.
No, there's
Did you do any demonstration?
We did a lot of
What is the story?
Did you guys parse
Where did they? Yeah. Yeah, very, very different.
All right, I want to make sure we have enough time for this last section. So we just talked about how to basically access stock ticker information from from Yahoo Finance. And I want to walk you through an example. The way we did it, just using regular expressions, we sort of want to take that to the next level and find a higher level way, sort of a simpler way of doing that. In Python, there's a tool called Beautiful Soup, which is a Python library for parsing basically the DOM, parsing HTML elements. It's much simpler, much more friendly way of extracting information from structured and semi-structured text from HTML and XML. If you guys, you should all make sure this is installed in your, either using pip install Beautiful Soup. I think it's pip install, I forget which Python package it is. Yeah, you should be able to install pip install Beautiful Soup 4, like this. Some of you might need to run conda install if you're using Anaconda. Excuse me. For conda, it's conda install beautiful dash soup. If you're using pip, it's conda install beautiful soup. It doesn't work? Beautiful dash soup doesn't work? Interesting. Wait, so you're saying, I guess it's kind of confusing because if you're using Anaconda, it's beautiful dash soup. If you're using pip, then it's beautiful soup 4. And I guess it's just one of the examples. Python is a very inconsistent package module system. Yeah, you have to do it within the bash shell. So you have to exit. Anyhow, we'll take care of it. If you can't run beautiful soup, that's okay. We'll sort of you can follow along and you know we'll help you on Slack or after class. But what I'm doing, basically what Beautiful Soup allows me to do is I'm able to, in a series of steps, I'm able to basically first grab data from a URL, just the raw text. So I'm basically grabbing the raw text. I'll break this down into steps. This is under 02 datamining.py.
Yeah, I have Anaconda.
Do you use it on your desktop? Do you use it on your desktop?
Pip is basically Python install package, right? It's basically, there's tons of tools that you can use to install packages within Python. Pip is the most popular, but there's a variety of others. I don't think we're going to have time to sort of set up the environment for each of you. So I guess, you know, we'll do as much as we can. But I think what would be most useful if you guys just sort of follow this and then run it, you know, as you get these set up, you know, on your own, then rerun it. So there's sort of two modules you'll need. You'll need Beautiful Soup and you'll need Tweepy. And again, don't get too hung up. If you can't install those modules right now, don't get too hung up on it. You can just follow along. Basically, we know the symbol of Apple, AAPL, and we're able to use this request object to get the raw HTML we want to mine, a raw HTML we want to parse. So if I look at raw HTML.txt, it's going to be massive, but basically this is just the raw HTML. What I'm seeing here is basically just this raw HTML on this page. Right, so I'm able to use the request object. This is another example of an object I'm using from the Python standard library. I'm going to basically pass raw HTML.txt into Beautiful Soup. Right, so I'm going to say Beautiful Soup equals Beautiful Soup raw HTML.txt. And now basically I've taken this raw HTML, this raw DOM object, and I'm able to sort of interact with it at a higher level. So remember how we were using regular expressions? Remember how we saw, you know, we recognized that there was a certain pattern of these you know, stock tickers that we were looking for. And it's this ref, it's basically ref with an underscore, followed by a series of digits, followed by an underscore L. This is the regular expression I'm going to use to find that object. So when I again, I'm just defining a standard regular expression tag. And so now I'm going to call this beautiful soup.find. It's going to find all span tags that have an ID that matches that regular expression tag, which I defined here. Right? So I basically, this is a span tag. And no, I guess it's the Google, I guess, has a little bit more of a consistent format. So we're using Google for this example. But basically, there's only one span tag that has an ID. So in HTML, the ID is basically a way of building a unique reference to what we call a node in the DOM. So every element that exists within the page, whether it's a paragraph, whether it's a div, whether it's a header, can have a ID tag reference. It's optional, but IDs are supposed to be unique. So if we can find IDs that match this regular expression, then we can sort of look within there and filter it down to find that specific value. And so I find the span tag by using this find field. For those of you who have used jQuery, or those of you who are familiar with jQuery, I'm basically doing exactly what I would be doing within jQuery. It's doing Beautiful Soup is basically in a lot of respects very similar to what jQuery does. For those of you who have used jQuery. So I'm basically just querying a particular element within the DOM, and I'm finding its text, right? So in other words, this span tag has only one. There's only one text item. In other words, text is what is not wrapped within. Or sorry, it was not within the sort of the metadata. In other words, it's what's rendered on the page. And you can clearly see when I select this ID, there's only one thing. I mean, even the Chrome inspector shows you that there's one element on the page that has the text within that particular ID. Running this, so I have the span tag here, right? If I cut and paste this into my terminal, I get a span tag. Oops. And I can just directly, Beautiful Soup just dumps basically the raw text of that tag, and I can call text. And I have, the U stands for, I think it's just like a U, basically, no, I think it's Unicode. Yeah, so there's different ways of formatting a string, but the U stands for Unicode. So again, we're seeing what we're seeing on the page. So it's not terribly complicated. Beautiful Soup makes it very, very simple. You can see how difficult it is when we don't have a tool like Beautiful Soup. To basically parse and interact with the DOM. We need to have these complex regular expressions, but Beautiful Soup, knows how the DOM works and allows us to sort of interact with the DOM at a higher level. So what we really want to do, though, is sort of interact with an API. And I sort of want to show you guys, go back to this example I was showing at the beginning of class. Remember this page, this Data is Beautiful page? And remember we want to basically find these attributes. And you can imagine it's going to be a lot of work to go with Beautiful Soup and being able to try to find and isolate each of these attributes. It turns out a lot of websites have what's called an API, which is an interface that basically provides structured information. If I go to reddit.com/r/dataisbeautiful and I type a .json at the end, and you can all do this, I get something that looks very, very different. You won't see it quite like this because I have a plugin extension, but I'll do it in Firefox. And look very closely at this. So this looks very messy and it looks sort of chaotic. When I format it and I have a Google Chrome extension installed, this is really a very nicely, cleanly formatted way of finding what we're looking for, isn't it? We can see each one of these is a post. There's a number of comments. There's a score. All the stuff that we were looking for here, all the attributes that we would have had to use, that we would have had to convert from unstructured information to structured information, we now have by accessing an API directly.
What's the extension that you have?
It's, well, the file extension I have, I forget which, it's called JSON View.
JSON View?
Yeah, so if you look at Chrome DevTools, it's called JSON View. And I just use it because I view JSON through the browser a lot, and so I find it helpful. But anyhow, This is what I'm talking about when I'm talking about the difference between structured and unstructured information. This data format adheres to a schema. And so what we had previously as being, really a raw dump of text, of strings, stuff that's messy and that we have to use regular expressions to process. What we now have, this is what we had previously. When we look at it in this form, we basically have an API, which provides us structured data. In other words, from that structured information, from that structured data, we can sort of define our own schema. When I say schema, we can define the attributes that we want and the relationships between attributes that we want. So we can basically mine, we can visualize, we can play with, we can extract, we can extend this data and filter it and use it as we please. And it minimizes the overhead. In fact, there's probably a lot of information here that's not even available within the HTML page. Like detailed information. Here's the timestamp, right? We talked about when we want the timestamp. There is, I don't know if there's a number of down votes. I see downs. Yes, but I do see a score, which is probably, really the score. I have the raw text of the title. So all this information, this really simplifies my life, much greatly. And also, what kind of object is this?
Dictionary.
Yeah, it's a dictionary. A JSON object is just a type of dictionary. So again, this goes back to, this is nothing here is specific to Python. This is all what we call JSON and JavaScript object notation. But you can see how the concepts and the data presented here is one-to-one, so to speak, with a dictionary. In other words, I can represent this in Python, and I can read it, and I can parse it, and I can work with it just as easily as I did, a native dictionary object. And there's really not too much loss of generalization when we're dealing with this kind of data. So let's see a similar example. By the way, I just want to finalize this point. Structured data has a schema. What do I mean by structured data has a schema? And this is, I guess, really the key difference between structured and unstructured data.
It's like almost repeatable. There's a blueprint.
Exactly. Yeah, it's like a blueprint. If I look at this, this is very regular, right? I can see, and again, it's sort of complicated. It's Reddit. It's a big website. But I can sort of map this out, right? I can see that this is sort of your top-level dictionary, top-level, what we call a node. And there's a data node here, sort of a bunch of meta information. But if I sort of scroll, I'm going to see a consistent format. I'm going to see that there's a data node here. In fact, nice thing about JSON View is it lets me sort of collapse these nodes, and I can sort of play with this. In other words, I can visualize this really like a tree. And again, it has a very regular format. And we're going to be, if we were sort of going to go about doing the analysis we wanted to, our schema would be fairly similar to this, but it would actually be a simplified. It would basically be a sort of a trimmed down version of this schema. So we would be looking at a series of nodes, and we would basically just take these attributes, filter out everything we don't need, and extract only the information we want. And we would be using a dictionary object to really represent that schema within Python. Questions on that? Make sense? Want to show you an example in Python of how this works. So I have here, basically raw data from the Twitter API. The Twitter API is a little bit more complicated than Reddit. Reddit, by the way, you can do this. This isn't specific to this specific Data is Beautiful subreddit. You can do this, anywhere within Reddit. So if I do r/all/JSON, it'll again give me that format. So this is public data that Reddit provides. Twitter does the same thing, but it's not quite public. I need to, in order to first access the Twitter API, I need to first, if you go into my Twitter account, I've set this stuff all up, but basically I have to apply for authentication credentials, so a series of keys and so forth. And I guess, I believe it's dev.twitter.com, but you don't have to go through the whole, you have to apply for keys, and basically gives me a way to authenticate with the API. And once I have these public and private keys, this is how Twitter identifies me and make sure that I'm not spamming the hell out of them. But I'll give you an example, right? So let's say I want to look up the number of tweets that are under a tag. So I have a tag, which is really just a keyword. And don't have enough time to really go through all this stuff in a lot of detail, but I've defined a method here that gets tweets on tag. And the OAuth handler is my authentication. So I send in my API key and my API secret. And I have to set also this access token, this access secret. In other words, the API key and the API secret identifies me and identifies my account. The access token and the access secret is per session. In other words, they expire. So when you authenticate with a web page, you have a username and a password, and that web service, that API, whether it's Facebook or whatever, will basically give you a sort of a session access. And that's basically what we're doing here. So this stuff is basically sort of formalities. And then once we get the auth token, or once we set up the auth object, then we can access the API. And I should also mention that I'm using a module here called Tweepy. And you guys will have a chance to play around with this a little more. But really what Tweepy does, it's really just a wrapper. It's a Python object that allows me to, rather than having to interact with JSON, I can interact directly in the native Python types. So there would be some overhead going back to what we saw here. Even though this is a dictionary, it's not quite a Python dictionary. It's very, very similar, and it behaves and acts the same way, but there would be some overhead of converting this JSON object into a native Python object. So I'll run this so you guys can sort of see what we get, and I'll dissect it. So this is actually processing a batch of tweets from Twitter. So I'm just getting get tweets on tag with the tag of Starbucks. And so I'm looking for anyone who's really mentioned Starbucks in a small period of time. Really the bulk of what's being done here is this API.search feature. Again, the API.search, the API object is really something that exists within Tweepy. So we have, say, Twitter. Twitter is here. And Twitter basically offers, there's the HTML version, the really what you interact with and what you work with every day through the browser. And then there's also the API, which again serves structured data. And this is in a JSON format. And then we have a tool within Python. We have a particular package called Tweepy. And what Tweepy does, Tweepy basically has a bunch of classes and methods, classes and functions which interact with, which are basically a Python implementation of interacting with Twitter. Python implementation of a Twitter client. Sorry if this is a little small. Maybe I'll draw a picture. So here's Twitter. The Twitter server. I should say servers because there's tons of them. Right? And these servers, basically, we have a client over here. This is us. We'll call this the client. Using Tweepy. And we make a request to Twitter. And we request that data in .json format. In other words, just as we requested data in JSON format from Reddit, we can also request data in JSON format from Twitter, assuming we pass in our credentials as well. We didn't need to pass in our credentials to Reddit because they're nice and they let us see the raw data. Twitter's a little bit stricter, and they want us to at least go through the trouble of getting these credentials first. So Twitter says, okay, we make a request, and in this request is just a URL. It's the same exact concept of making a request in your browser. It's just like going to gmail.com, google.com, twitter.com. Those are all requests. We're making a particular type of request called /tags. And again, we're just hitting a URL. Just like in my browser, I went to reddit.com/r/all.json. This is just a request. We're doing the same thing here. And so Twitter responds with a bunch of structured information, this dictionary that we talked about, that has all of these tags. And we said /tags, and we passed in as an argument, I think Starbucks. Tag equals Starbucks. And so Twitter says, okay, I'm going to give you, the first n tags with Starbucks. And so basically, it gives me a list. It returns basically a dictionary containing a list of tweets. So like Stargirl14 says, Stargirl with a U says, OMG, Starbucks, heart. A bunch of other crap comes in. So what we're getting here, this is the tweet in API.search. This is the request. This line, this particular statement here is what makes the request. This is the authorization. This is the request. Then for tweet in API.search, that's each tweet in that response. I can loop through that, and I can do as I want with that tweet. Notice how much simpler this is than even Beautiful Soup is relatively simple because Beautiful Soup is well designed. But notice how really the format that I get here is very clean. It's very amenable to, it's all in Python. I don't have to deal with any raw HTML. I don't even have to really look at the JSON objects. I can just directly within Python, not have to worry about the API directly. And this is what we call an API wrapper. In other words, Tweetbee is an API wrapper. So basically, we sort of look deeper here. We have this data going in and out as a type JSON object. JavaScript object notation. JavaScript object notation. It's a standard format, universal format. But Tweetbee, so this is basically within Python. And then we have basically this Tweetbee module here. That's what we call serializing and deserializing, converting and sort of deconverting JSON into native Python dictionary. And this is sort of Tweetbee. So we're actually interacting with Tweetbee within the Python environment. So part of your homework will be to get up and get this stuff running. It shouldn't be difficult at all. We'll make sure that you guys have all the tools that you need. Sort of similar to the first homework, you might need to install some packages. And we'll recap this shortly, briefly, on Tuesday. But we're going to get into some more fun stuff, like interacting with some of the tools we're going to be using in data science. And yeah, some of the more sort of extending on more of the fun stuff we did today. Questions on this stuff? Make sense? Okay, cool. There's also, just quickly, in this repository, in your DAT NYC under assignments, you will see assignment 3. It's a pretty straightforward assignment. Basically, you'll be going through. Oracle has a great list of machine learning algorithms. Just sort of getting you guys to think about and read some of the literature on the techniques and what's used in practice, and really setting up the premise for what we'll be learning later. And a lot of this stuff will be new and foreign to you, and that's great and fantastic because you'll be learning it. But this is stuff that we'll be covering, really in 2 and 3 weeks. And so your mission will be to choose one of these algorithms, choose one that's relevant to you that you want to learn more about. Read the Oracle document on it. Read the Oracle document on it, and just write a short write-up, a short report on it. And yeah, I'll send some follow-up stuff. We'll send some additional, the TAs and I have some additional information on you about stuff like projects, et cetera, which we'll send over Slack. Also, last but not least are the exit surveys. Josh, do you guys want to, Deepti, do you guys want to pass those out over Slack right now? Okay. All right.
question. Just packages. I say the other day, I'm still really new to most programming, but I've been learning and like RFSs, like lots of tools, like and references online, doing write-ups and documentation for every package. I see that some of them live on like some pythonsite.org. Like, is that like the crayon of Python?
So one thing that R is great at that Python is less good at is that there's a standard, means of formatting like on crayon. Python doesn't quite have the same thing as crayon. There's several sources. So for instance, like on Beautiful Soup, there is most packages have their own Python documentation either on the GitHub or on a website. Like with Beautiful Soup, and if you Google Beautiful Soup, usually there's a website like this, or there's you'll see documentation, and it's usually like in this sort of format, like the default Python documentation format. But usually when I'm looking for a package, like I'll be looking for like Tweepy documentation. I'll just like Google Tweepy documentation, and that's usually my go-to place. Like Google's typing whatever package name in the documentation, and that's usually my go-to place. And most packages are good about documentation, but it's not as consistent as it is in Python.
Okay. Yeah, because I think that's just a matter of practice, I guess, as well, just seeing what's out there and learning by Google.
One thing that is helpful is I recommend that you use IPython, because one thing that's great about IPython is, if I go into IPython and I say like import BS4 as Beautiful Soup. I can say Beautiful Soup and I can tab complete, which is great because I can see all those methods. But then if I say like beautiful soup dot, if I look at like a dot beautiful soup, so if I look at the constructor, right, I can follow up with a question mark and get all the documentation for that particular function.
So you do it within.
Yeah, so it is extremely helpful. Another thing that I use a lot is a tool called Dash, which is basically just a repository for all this documentation, and it has almost every tool you can imagine, like Python, virtually everything. And so I think there's, it integrates with, a lot of integrated development environments, but it's a great tool to have.
Okay. And I saw you were using PyCharm.
Yeah, I use PyCharm as an IDE.
Would you recommend that too? Or like,
I would. It's not, so I purchased this copy. It's not free, but PyCharm is probably the best Python IDE out there, in my opinion. It's just powerful and it works, and I recommend it.
Okay.
It's a solid IDE. It's very solid IDE.
It seemed like it was really helpful to be able to go. Because it's another thing with our studio. There's the command line, the text editor, and all this kind of stuff, and the documentation all in one place.
Right.
And
exactly. And yeah, PyCharm does have. Well, obviously IPython is really the great thing about IPython is that when you're within a notebook. So if I start up, for instance, a server. So if I do IPython notebook, right?
Did you rewrite history?
Yeah, I did.
Yeah, it's freaking up everyone's thing.
Was it really?
Yeah.
Oh, I'm sorry.
It's okay.
No, I sort of did it in a rush. That's why. But so I can open up an exercise, right? So if I open up.
It's in Iowa.
Maybe this one isn't the best example, but
I definitely, I'm pretty sure they said that it's going to be out on Slack with everything that we need. But I want to check it. Yeah, but it has to be like Okay, great.
so if I say, evaluate this module, I can, let's evaluate this first. I can do like NumPy or do like np dot, and I can tab complete. So I can like read, like tab complete to like read CSV, right? This is something we'll cover on, but I can also do a question mark, or I can do shift tab if it wasn't in there, I could do Shift Tab to get documentation. But I could also, you know, like evaluate. I don't know why it's giving me an error. Anyhow, yeah, you can get documentation by basically doing the question mark. So I'll do import PD. Right, so I can see exactly. So you can see I'm getting the documentation right here. So actually, there was actually a documentation browser within FF.
Should they write things on the phone and then submit the requests? Or
Yes.
so the only reason that it makes sense, but like they have to to keep their form safe.
Yes.
Did we go over that?
No, I'll post an article on it on
Okay.
Slack.
Yeah. So.
Yeah, but I'm not sure if like.
Thanks for because I was trying to read up on all this stuff about things and the packages rather.
Ton of stuff out there.
Yeah, but so it's helpful to organize all that and having tools in the environment is helpful.
Yes, IPython is very good at that. Yeah.
Thank you. I appreciate it.
Sure. My pleasure. Yep.
So when you're working with the Twitter API and you define a function, are you going to like include the API key secret, the token and secret like in the block of the function every time you define a function?
Not every time you define a function, but every time you access it, you do it once. So basically, you would extract, in this case, and get tweets on tag. You basically do the authorization in some initialization function that only gets called once. And so basically, I would keep a reference to the API object. So once the auth object is already authorized, I don't really use it. So as long as I would basically keep a reference to the API object, probably as a member variable or instance variable or class.
Oh, okay. Okay.
And then just do it that way.
Alright. Cool.
Yeah, so the API object is really what the key object is that I'm using within it to make those Twitter API calls.
So what I understand is you just like this, and then that part, you'd be missing the same part. So what would be all of it?
Yeah, but exactly, but that's what I did. I did this and then
I think I know. Because the one, so I was missing this thing. So what I did. So what I did was,
And there's bring an eraser, like an actual eraser, right?
Yeah.
yeah. So
It's about the same. I mean, this is about the same as the eraser.
So yeah, just try running. So try running the file. Yeah, I don't know. Yeah, so please try it, or just try to just those files. Right.
So do I need to be invited?
So let's go ahead. That's why.
Sorry. How much did you buy?
No way. Can't catch a break. No tea. I'm like out already.
Yeah.
I just, I
Texas. Well, I need. Okay, so here's the class. was like a huge name, so I was yeah.
Spider installs, like a radio check for package installs.
First 5 days.
I don't think so.
So he says this is
Yeah, this is a ridiculous shot.
Spider,
Okay.
but I'm not able to find it. He basically just downloaded it from computer.
Yeah.
But he's
Well,
not able.
Then I guess you would basically install a credit within wherever your Python packages are.
But I don't know where to find his Python
There have been so many other reasons.
So private spiders are using Python version. Well, no, that's right. You can probably define whichever Python. Yeah, if you can use this command line.
Thank you so much.
Okay.
So if there's a configuration somewhere that's set in the original Python.
I mean, like this was wrong completely, so.
Yeah, so it's using
This is just something that I understand. Like, I understand that JSON data is like dictionary data essentially with like values and hashes. I mean values and the keys. Right? It's a good way to like access information and you can parse it.
So
You get information by yeah, I know we like I understand conceptually what's going on. I don't think I understand it any kind of like how to actually which is like a little bit of double, but right.
Yes.
Well, you not know what you have to learn that shit.
No, I
Alright.
Seriously, rest your brain.
What was that thing that you were doing to regular stuff, right? And you can use that in like just use it for like in
I use this tool called Teacher, and let's say it's terminal. So it's creating ID terminal, yeah, on site, Python has it. It's not free, but you can get, you can actually get free version.
Was the visual soup of parsing?
I know, you can select and you can not at all. I think I'm supposed to yeah, well, you have to also make sure you have beautiful soup installed, and I guess there's a lot of stuff. Details. There's one thing with the Python. Things like that. Understand that.
Yeah,
It's just
I guess the idea of that is that there's two different parse and structure data you order, so there's some types of things like JSON's
usually pip install
is taking what we see as structured.
well, if you're using Anaconda, then you can use Conda install to
right?
I think.
No?
and if not, I can just Google it.
Yeah, so Conda is actually a little different. I believe it is.
Unstructured data is unstructured data is also like
What? Give me first meeting.
the HTML that's like pretty unstructured. But when it's in when you do that API,
When you showed us regular expressions and you showed us beautiful soup, they both like search and parse.
They both work together. I mean, you notice like in that example of beautiful soup, I'm actually using a regular expression to define where the tag is.
Yeah.
And then I'm just using beautiful soup. So they're sort of complementary to each other. Beautiful soup internally uses a lot of regular expressions, but typically you'll use them to together.
Okay. So we'll be learning them. We should be learning them like so like concurrently.
Yeah. I mean, beautiful soup is specific to Python, but regular expressions are used everywhere. So yeah, I mean, regular expressions are a lot more applicable, broadly applicable than beautiful soup is.
Okay.
So I think.
But for the purposes of our course, like we'll be using beautiful soup in Python.
We won't be using it too much until it's maybe towards the end of the class. It's not too. This class, most law stuff we cover in this class is mostly. It's not stuff that's particularly applicable to stuff like data modeling. So we'll it might be if you want to use it for your final project, then yeah, it's useful. But most of the stuff that we talk about in the class are independent of beautiful soup. It's not directly coupled to the stuff that we talked about in this class. It's useful, broadly outside of this class, but I sort of introduce it because there's many ways of scraping, and beautiful soup is probably one of the best scrapers. And in practice, you might use one of the many scrapers, but beautiful soup works well for what it does.
Do you understand that part?
But it's more common that you interact with like APIs than you actually scrape. Like the API stuff that we talked about with Twitter. Like that's usually how the preferable way to get data if you can.
In that case, you would use you could use like regex or beautiful soup in Python.
Well, for APIs, you would just basically be using the raw, like the request object that I showed in that example. So basically, you wouldn't really need to use regular expressions at all. Because it's already structured that information, we don't actually.
Request object is.
It's basically a way of making HTTP calls or requests to a server.
Okay.
So it basically just says.
You get the JSON.
Exactly.
Okay.
It can even be HTML. Like in one example, it was HTML. So it's basically just making an HTTP call to a server. So exactly it's basically just like a browser. It's just like a client. It's a browser without all the fancy stuff that a browser has. It just gets the raw data from the server.
And then from there, you just parse through it and mine through it.
Exactly. Yeah. So I mean, depending on what the data source is, if it's JSON, then you could basically just convert it to a dictionary. In other words, you'd basically parse the JSON. So you convert the JSON object to a Python dictionary object, and then deal with that. So you basically you can filter out the information you don't want.
But that filtering is done through either regular expressions or.
No, it's just done directly, like how we talked about how we can query individual objects. We can either build a new hash, or we can just delete items from the hash. So once we have that hash object, we don't need regular expressions at all. So regular expressions.
Just delete it if it finds it, then you can just delete it. Or,
well, a dictionary object is basically.
The only thing I would say about
it sort of looks like this, right? So we have, say, ID. And if we have, say, score, and then we have something like title, like the stuff that we're interested in. And we have some estimates that we're not interested in, like I don't know, username. This is just a dictionary.
Yeah.
I can just say delete. There's a Python called delete.
Del, yeah.
I can just delete dictionary username.
So then after that, you'll just be left with a dictionary that has that removed.
Yeah.
You'll just have ID, score, and title. Okay.
So it doesn't. The regular expressions are needed to query the dictionary. The full strength of the dictionary.
Okay.
The regular expressions is for finding that's what I talk about with finding structured information and unstructured information.
Yeah.
Basically identifying keywords. So if I give you.
Regex is to parse HTML. HTML is not regular. Unless you're doing a quick and dirty thing. Yeah, it's different levels on the grammar.
Yeah.
But it's just for examples.
Right.
Okay. Okay.
Yeah.
Right.
Exactly. You can use regular expressions to parse HTML, but regular expressions have inherent limitations that you can't quite get as granular. Yeah.
The only thing I'd mention differently about dictionaries is that keys are immutable, which I think is important.
Keys are immutable, yeah.
That's right.
Because they're basically
it's a hash,
raw
so
objects.
they hash the key.
Exactly.
That's why it's called a hash.
Okay. Thanks, guys.
That's good?
Did you just, what question did you want to ask?
Tell who knows how much Python. Did the recording work? Are you
Huh?
Yeah. Okay. Did it work?
It won't work.
The recording?
I don't know, I haven't checked yet. I think it worked.
Maybe I should pause it before it gets.
Yeah, I know.